Hello, everyone. Welcome, and thank you for joining us today. My name is Ray, and I'm going to be the moderator for today's webinar. A couple technical things to go over first. We are going to have a Q&A session at the end of the webinar. If you scroll to the bottom of your screen, you'll see a little Q&A box. If you click on that, you can type your questions right there, and we'll get to them at the end and start going through those. This webinar is also being recorded, just so you know. And then we will send it out to all of you after the webinar, so you'll have the recording and you will have the presentation. Other than that, we're very happy to have you here. Good morning, good afternoon, depending on where you're located. We have two amazing presenters today, Brooke Cronin, one of our senior UI UX designers, and then we have Thomas Hartman, Senior Manager of R&D. And with that, I will pass it over to Thomas.
Hello, welcome to How to Turn Your Design Visions into Functional Products. Today with me is Brooke Cronin and I'm Thomas Hartmann. Today we will demo the new features like the material editor, Figma variants, and we will highlight UX improvements that we did in the last versions. After that, I will show the outrun demo in Qt Design Studio and show how the new particle effects work. Then I will show the design viewer. And last but not least, I will show how Qt Design Studio integrates with C++ and Qt Creator. The material editor was recently added to Qt Design Studio in version 3.5. So it's safe to say it's the latest really bigger feature. And the material editor comes in two parts, the browser and the editor. And before, if you are familiar with Qt Design Studio, you had to use the navigator and the property editor, and everything was a bit peculiar, and now you can have the browser where you can easily create new materials, duplicate them, assign them. You have a specific editor, so you don't have to use the property editor. Now you could use the material editor, which is a bit optimized. And the browser also makes it really, really easy to assign materials to your scene, as you can see here. So all in all, this unifies the whole experience with other 3D tools like Blender, so you will feel a lot more familiar. And yeah, it makes it really easy and intuitive to use and manage materials. So I think this is a huge user experience improvement from what we had before. You can also search the material library, so we'll see all the materials in your document. You can easily search them, then edit them, assign them. And yeah, I think this is a really great addition to Qt Design Studio. Now I will give over to Brooke Cronin here, and he will start with UX improvements.
Thank you, Thomas. And yes, before we get into the, arguably more exciting stuff with the Figma variants, I just wanted to have a quick highlight of some of the UX improvements. And you actually saw this in the material editor too. But what we've done is we've actually added search filters to important areas like the assets management panel or searchable combo boxes or the navigator itself. Wherever possible, we've even added these kind of thumbnail previews for image assets, be that again in the asset library or the property view, and functionality like drag and drop. So being able to just drag from assets directly onto combo boxes in the property editor or directly onto the items inside the navigator. All in all, trying to improve that user experience, especially when we know that it is difficult with large projects, with a lot of assets, with a lot of objects, sometimes to find that thing that you're looking for. So we've been working hard at these kind of small UX improvements, searchability, filterability, previews, drag and drop, wherever applicable through the Design Studio tool. And hopefully that will make using Design Studio a lot more fun and a lot more intuitive when it comes to these larger scenes. Okay, let's move on to Figma variants. For those of you who don't know what Figma is a design tool. It's used heavily for UX and UI design. It's commonly associated with what we call creating design systems. And it is in that way very similar to a lot of these development concepts. So you have the idea of components, instances, even states or override properties, terms that would be familiar to a UI designer using QML already. So you can see here that these components that I've designed have different variants, what Figma calls variants. And that translates very closely to what we would call states in QML. So we are actually able to design these single components with their states in them, and then, as shown here, combine these together to create a set of instances of these components into other components. So starting that process of componentizing your design, thinking about your design structure. And then you can even set the different states that should be displayed. So here we have instances of this button component. And when we go in and when we actually have a look at these, you can see here on the right that we also have the state. So because we've designed the states in Figma already, we can actually set them in our design. And the Qt bridge for Figma is actually able to capture all of this information. So not only will we be exporting all of these components, we will also be generating all of the states for those components. So in this case, you'd have this scroll down here, you see here we have this normal and active state defined in our design. And what we do inside of these things is we actually, capture those QML properties, we create property changes, we bring in rectangles or SVG paths or for vector objects, and wherever possible, we are capturing those property changes directly into QML. And you can see here that this is an import. There's been no sort of fakery or fiddling here. This is literally a direct import of my Figma file. And I can dive inside this button that I looked at in Figma and show you that we have been able to create these states directly from the Figma design. So we have this normal active state. We can instantiate it here, and we can also set that state here in Design Studio as well. So I can change that back to normal just so you see it's really working there. And so you can go a really long way to capturing the full design intent of a designer this way. You can have your states, you can build screens, you can build component stacks with nested subcomponents, and you can already define different states inside the design itself. So these sliders have a different state here for this sort of active and inactive. And of course, in reality, you would want to go in and add when conditions to all of this to make this truly dynamic. But you're already at a point without touching any code where you could pass this over to a front-end developer and they could take that work further, add the correct when conditions, and then you would have your working design. And so you can see here, I think if I scroll down to, yes, the state changes, and you can actually see that rather than just having PNGs or SVGs for your assets, what you actually have are QML rectangles with proper color changes. So the handle and the underline and the fills and the backgrounds, these are all native QML items, which mean, of course, that they can be animated or they can be data-driven, or you can change the values for the colors in a theme file. It really gives you this full flexibility of a sort of native QML design coming directly from your Figma design. And when there is no sort of suitable QML equivalent, so if, for example, certain shapes cannot be represented well in QML, then it's going to fall back to image-based or asset-based output. So it always sort of gracefully falls back to whatever format it can manage. And we can just have a look at some of these other components. So this small button here in this little sequencer has all of the states that were defined in the design. And that can be nested into this component, and that can be nested into a screen design as well. So we already have a really gone a long way with what you can do with Figma. One of the other things that Figma now supports is constraints, which are the equivalent of QML anchors. So what that means is when you set a constraint in Figma, in this case, you can see here that I have this left and right and top constraints added inside Figma. And that's added to all of the versions of that in every state. So in this case, it's to the bottom for the bottom bar. And in some cases, it's left, right, top, and bottom, which equates to fill. And again, inside here, we also have these constraints being used. If it's just left and top, like that first one was, then there's no constraints added, but everything else generates an equivalent QML state. So what we can do is we can start to compose these responsive designs already in Figma. So we can have constraints inside the components themselves. So the text label in this is always constrained to fill that button. And therefore, as we rescale the button, the text is going to stay anchored to the rescale button. And we can also, when we use an instance of that component, as in here inside another component, we can also then constrain it at that next level up as well. So we've got constraints happening inside the components internally, inside these button components. You can see that they've been rescaled, and that's that button as well, that the button itself has been rescaled, but it's also constrained to the next component up, so that at a certain point, when you start to rescale these composite components, everything inside them is going to rescale according to the constraints and anchors you've given it. So in this case, this is 2 copies of the same component, both then given a different form factor in Figma, and allowing the Figma constraints to then define that sort of rescaling behavior. And I can export that. You saw me there, just export the archive. I can bring it in here directly just by dragging that bridge file into the form editor. That's going to trigger the importer. Again, another little feature that we added to make these workflows as easy as possible. It now has to pass all that QML data and write the components itself. This takes a few minutes, not a few minutes, but a minute or less, perhaps, depending on the complexity of your files. You see there, it's writing these components. And when we can close that, we'll go inside the folder that it's generated. We'll go to that screen, and you can see there that we have those 2 components from Figma with those constraints converted into anchors, creating responsive UI elements directly from that Figma design itself. So if we go inside that to actually have a look, because that top level doesn't have constraints yet, but inside here you already see that the anchors have been generated along with their margins, their positions, and what they should be anchored to. And if we have a look at the code for that, you see there that where an anchor has been applied, where a constraint has been applied, there's no longer fixed X and Y values. It's all relative to the parent anchoring. And that's the same inside the component. And then when you've then anchored that component somewhere else, and on the top level here, these have hard-coded X and Y values because they're not yet, they don't have constraints. But what that means is, because I can then change the X value, I can drag out the X and Y of my component, and you can actually see those anchors working directly in real time. And as I said, there was no code added at all in Design Studio. This is all literally directly one-to-one from what I did in Figma to what I was able to import into Design Studio. So variant components with states being generated, plus all of your anchors as well. And with that, I'll pass back over to Thomas.
Yes. So thank you. Thank you a lot, Brooke. So what I want to show you is the outbound cluster. The outbound cluster is a demo that was created by a team of designers, technical artists, and of course also developers to really push the limits of Qt, QML, Qt Quick 3D, and of course also Qt Design Studio. So let's open that project. It's a really large project, so it can take a tiny bit of time to open it. So it's loading now. And here you see the main screen with the states on the bottom. I will talk a bit more about that later. So states were heavily used. But first, I really want to give you an impression how this demo works in practice. So this is now the cluster running. And yeah, as you see, it's really a high fidelity demo. A lot of work went into this. The team took something what they called the cinematic approach. That means the different states of the UI for the ADIS screen, and there's also performance mode you will see, and so on. They are done with camera movements, and that's very impressive. What you also see is that the models, the general effects, everything is really done very well, has a really, really high quality. So the team took really a lot of time and effort to polish this. And because of that, Design Studio was crucial in the process. And I think there are many improvements were basically feeded back to Design Studio to help the people, the technical artists especially, who worked on this. So we learned a lot. And also some feedback, of course, went back into the framework. There's also the light mode here. We see the performance mode. I can use the keyboard to drive this. There are, of course, also 2D elements here on the bottom. So Qt Design Studio is also really good to basically integrate the 2D parts and the 3D parts of your UI. Here we see again this cinematic approach with the camera movement for the charging station. And I hope you got an impression that this is like a really, really cool demo, and it's part of Qt Design Studio. So if you install Qt Design Studio, you can download it from the example and demo reel. And yeah, as I already said, there went a lot of work, really a lot of work into this. And I think it really shows. I think it's a really impressive demo. I think it's the most impressive demo right now in the Qt context. And it's really a new standard for demos right now. So let's just play around with this a few more seconds. And then I want to show basically how this project works in Qt Design Studio. Okay, now we are back in Qt Design Studio, and on the bottom you see the states. The states generally define different camera positions for the cinematic approach. Also in the navigator, you see that this has quite a complexity, and we have 2D elements here and 3D elements. So the compositing of 2D and 3D is really something where Qt Design Studio shines. So now I went into the component of this panel here, and yeah, that's how it was designed. So you can always drill in and then drill back out. There are more 2D elements, so let's have a short look at them. So again, you can drill in, and in this component now, all the 2D elements were composed and designed. And you can all do all of this in Qt Design Studio. It's 2 tools. It's 1 tool for 2D and 3D. And now I go back to the main file, and we actually have 3 3D scenes here. We have 2, not 3. We have 2 3D views, and yeah, here you see them in the navigator. And let's now go to the 3D view. So this is a 3D scene that was used for the effect of the performance mode. You see there's a camera, and if I switch the state, kind of see how the effect was implemented. So we really extrude this thing in the state or scale it into the Z direction. That was how the performance mode effect was implemented. And then we have another view, and the 3D view will always show the selected one, or where you have a sub-selection from. And yeah, this is the 3D scene that implements the ADIS view. Here we have the car, and we can take over the camera to the view of the camera, but also do the other way around. So now we really see through the camera of the view. And yes, the Outrun demo also has another part. The other part is the HVAC demo. So I will now open this one. HVAC stands for heating, ventilation, air, and conditioning. It is just a different part of the whole Outrun experience. And yeah, it's a different project in Design Studio that I just opened now. And it shows a couple of different aspects. So that's why I also want to run through it. So it's not a cluster, it's HVAC configuration system. And it's done in a similar way. So we also have these top level states that define the different modes with the different cameras. But yeah, first I want to run it. So you see we have a really high fidelity model here, and utilize particle systems for the airflow. I really like that effect. We'll see a bit more about particles later. Yes, and we also have these state transitions. So it's a bit different. It's not just the camera, there's more here. And I really, really like how this is done with 3D to adjust the seats here. think this is really impressive. It really shows the power of Qt Quick 3D. Here we can configure the sound points. Here, a developer has to help out the technical artist to get this effect really right. But this also really shows the power of the design studio. So it's really a tool where developers and designers and technical artists can collaborate on the same project, on the same application. Okay, now we are back into Design Studio, and as I said, you see the states on the bottom. It's relatively similar to the cluster in a sense that we have 2D, we have 3D. In this case, we only have one 3D scene. Again, let's go into the scene. So here we see the car from the outside. We never saw that in the demo because we are always sitting in the car. Here, it's now a nice feature that I can select the camera, and then I can take over the view from the camera. Let's do that once. Select the camera, and then I take over that view. And now we basically see what we also saw in the run demo. That's the same perspective. You see that I'm not a technical artist, I'm not that familiar with editing the camera, but yeah, you get an idea how you work with, how you do the setup and everything. You tweak the materials. Now I go inside the component of the car, and you can really see it's a high quality model, like really high quality. And yeah, let's just for fun change the color to green because yeah, in the context of Qt, it's a logo color. Just select the correct material and then go green. Could also have used material editor here, but you can also do that still via the property editor. And it's an old project that has a slightly different structure still. Okay. I hope that gave you an impression about what's possible with Qt Design Studio, and also what you can do with it, and also how much time you spend on the cluster on the outbound demo. Now I want to show you a bit more about particle systems. I just load the project right now. You already saw how the particle system can be used in the context of the HVAC demo. But yeah, I just want to go a bit deeper. So this particle systems is integrated with Qt Quick 3D. So it's not the old Qt Quick particle system. And you can see we can do fire, we can do this firewall, we can do water, and then you have these different layer particle effects. And I think they're quite impressive. And it's up to you basically how to utilize that in the user experience, in the UI. But now I open the Fire file, and you can see I can turn on the particle system and play it also in the 3D view. That can be very useful. We will only visualize the selected particle system, and only if you turn on the feature, and then you can pause it, and this way you can preview it and see the particle system from all angles, and that's a very useful feature. You can tweak, of course, the properties. It's a usual particle system that comes with things like emitters and of course the particles itself and so on, but just sprites for the particles. Now I also run the live preview, so we can have both the live preview where you see it from the view of the camera, and then also the 3D view. And that's how I would typically, I also actually created this file here, how you create these demos. The fireball is actually significantly more complicated. Really shows what's possible with particle systems or particle system. So it has one emitter with a shape in the form of a sphere. That's kind of the main emitter, and creates these glowing dots on the sphere. But some particles are so-called trail particles, which are emitters themselves again, and that's how we do these small fires. So basically, we have particles on the surface of the sphere that are particle systems themselves, and then they create these small flames. A lot of stuff is done via the correct sprites and by layering a couple of these particle systems. That's how we get this rather impressive burning sphere. There's also a bit of smoke here and there. Yeah. I hope that that gives you an idea of what's possible with the particle system. We didn't cover all features here, but the shape emitter is important, and I think also the trail emitter. Then Qt Design Studio comes with a couple of presets for full-blown particle systems. So we have a couple of particle systems that really come with Design Studio, and also a couple of building blocks with good presets. So we have basically a working model shape or a tractor and so on, and you don't have to tweak everything or set up everything from ground zero again and again and again. Yes, so I think this is really useful, and you can also try out the particle systems. So let's now have a short look at the water. Yeah, there's not too much special about the water. It's a relatively simple particle system, but we have an effector that defines force, which is gravity, and that's how we get this nice spring-looking form by having gravity here. And yeah, you can tweak it in the property editor, of course. Currently, it's bounded with header. Yes. So that's about particle system. And the next thing I want to show you is the Qt Design View that exists in kind of experimental state for a long time, but this now has a new URL. And it's basically, it allows you to run designs in the web. It comes with a couple of designs preloaded, the good old coffee machine, and also the e-bike demo. So you can just enter this URL here and try it out. And these are the QML projects from Design Studio without any changes. And we ported now the Design Studio to Qt 6.2, no, 6.3 actually. And it also now supports WebGL 2. And this is also why we now have 3D available here. The old experimental Qt Design View couldn't do that. And yeah, we are actually continuing to improve this. So also stay tuned. There will be some improvements. But what I also want to show you is how you can deploy your own designs to this existing design tool. So let's open the Figma example. That's just the Figma example that comes from the example browser and that Brooke worked with. And we can generate and deploy the package that will generate a so-called QML file for you. I will write the existing one. It shows you what it adds to the QML file. Then this file was generated. And now the only thing I have to do is I have to drag this file onto my web browser, and then it will preview it in the design view. And in theory, you can send this file to anybody together with a URL, and you can easily preview the design without any installation, nothing extra. No, short compilation step. Now we see the Figma demo running. Yeah, because the Figma demo is a bit boring and does not do much, I want to do exactly the same now also with the robot arm demo that we added to Qt Design Studio. So we go back to Qt Design Studio. And we open the robot arm demo. Yeah, we will talk a tiny bit about this demo also later on. It has integrated 2D and 3D. So it also has 3D elements. They are interactive. So we can think of this like as an industrial robot arm that they like seeing. And I can do exactly the same. I can deploy the package again, overwrite the existing one, and then I can deploy it. This workflow we will improve in the next version, so that's not the final workflow. We are streamlining this, but even with the current version 3.5 and the upcoming 3.6, it works like it's shown here. I think it's already very useful because you could have sent this file to anybody, and together with the URL, everybody can now preview it. And you see, even though it has 3D content and so on, it's working quite flawlessly in the web browser. Okay, now we come to the last topic of this webinar, a very important topic. It's about how do I get my projects running in Qt Creator. So here again, I have the Figma variants, and I just want to run it. But the question is, how do I create a C++ application out of this, and how do I integrate this with Creator? So now I have this application. It kind of does nothing at this point in time, but that's not the topic. We also do it with a robot arm demo later. That's a bit more interesting. And the question is now, how do I turn that into a Creator application, a C++ application? In theory, I can just open a CNAC file that was created by the wizard initially, and that comes with each Qt Design Studio project. I can open that CNAC file, CNAC files.txt, and configure it in Creator, configure the correct kit, build it, and then run it. So it's in theory, it's as that simple. So let's do it. Did compile, good. Now I run it. And now it doesn't run, and I get an error message in the application output. Yeah. Let's check out the application output. What's wrong? Yeah, file is missing. And this is because the CNAC files .txt that come with the project are still the ones that were created initially by the wizard, and they are missing the new files that were added to the project later. And we can see that if we open the file here. So it's basically missing all the QML files that were added as part of the project. Luckily, we don't have to do that by hand. So in Qt Design Studio, we can go here and we can basically regenerate those. Don't even have to care about the details. We basically just run this small wizard, and now we have the latest CNAC files. They updated them for us, and that's really how it works. There's none. It's still a manual step because in theory it could break, and we are thinking about fully automating that. So whenever you save the project, we'll just execute this step. And now if we build again, you see that it's compiling a bit more. So yes, there are all the other QML files that are compiled. Because since 6.2, the QML files are actually compiled to some degree by default. And also, it's important to notice that this feature only works with Qt 6.2 and higher. Because the functionality required from Qt for the CNAC build system is only there since 6.2. Now I opened the robot arm demo, I run it again. So you already saw that. It's a bit more interesting. This is why I now use it. Here I skipped the CNAC generation part because we should now know how it works. So I already did it. And also, if you download any example from scratch, of course, the CNAC file is instant already. So, and this here comes with what I call a fake or mock backend. So this application actually has a backend in C++, and it has a very, very simple backend defined in QML to mock the C++ backend, so it runs in Design Studio. It's basically just filling out the API so that it runs here and adding a tiny bit of behaviors and animations. And I can open the same project here in Creator again. As I said, the CNAC files are already in sync, so I didn't have to do that. Just build it. And now it's running. And actually, in this case, not the mock backend is used, but the real C++ one. That's because the import path for the mock backend is not set in the C++ case, and also it's not even part of it. Yes, and let's prove this. So I put a debug here in this detect collision function, because this is actually the part that we kind of skipped in the mock backend. So in the mock backend, there is no collision detection, nothing. This is only implemented in the C++ parts. And as you can see from the output, it's really calling that function. So we now really execute the C++ backend instead of just the QML mock backend. And as you can see, it's basically implemented here as a C++ object and with properties, and that defines the API. And then we have this that subdirectory here for the backend, and then we have a CNAC file that generates this module. This is the backend again with the properties. So we have the status and the angles that we then bind to the front end. And here you see the module itself it's just for files. And yeah, this is basically how we define the build system for the C++ backend. And it's a QML module, and that's why it's so easy to mock up into Design Studio also as a QML. And before we end the talk, we just play around a tiny bit more with this product arm demo. Okay, with this, it's now time for Q&A, and I can already see that there are a couple of questions. So let's start with a Q&A session. But first, thank you for your attention, and yeah, really appreciate that so many people joined here, are interested in Qt Design Studio. So I will start with the first question. Is it possible to generate Figma file from QML code? Yeah, that's a question I think we had a few times already. Brooke wants to answer it. I can give over to Brooke and then say something maybe later.
Feel free, yes. Yeah, you go first then, Thomas.
Yeah, okay. Yes, as I said, we sometimes get this question and kind of would allow full round tripping. In theory, I think it would be possible. And we have a prototype for Photoshop that is part of Qt Design Studio, where you can create Photoshop files from Qt Design Studio. It's just not on the roadmap at this point in time. We probably will investigate that a bit more. I think why you would want to do that is to create scaffolding from QML. So you basically can set up the information architecture and the scaffolding in QML, then generate the Figma, then go to Figma and make it look nice, and then bring it back to QML. That's at least our use or the use case we see here. But as I said, it's not on the immediate roadmap at this point. So maybe Brooke want to add something?
Yeah, I think that covers it fairly well, Thomas. It certainly is something we've heard asked a few times for those reasons that you outlined, that actually in some cases people want to start with the architecture or the structure of their UI inside Design Studio. So assuming that means that it's defined by engineers rather than designers, and then to be able to create the artwork templates from that QML wireframe or scaffolding, or however you want to call it. However, it isn't traditionally the way that a lot of this work is done that we see. So most people tend to start from Figma, from the concept design, and work outwards from there. But as you said, it's totally feasible technologically. We could do it. I think it would just be a question of whether enough people really wanted it, that it was prioritized into a roadmap at some point. So perhaps you should consider creating a suggestion on our bug tracker, and that way we can gauge the interest in this feature. Okay, should I take the next question then, Thomas? There's a couple of Figma ones here that I think I could answer.
Yeah, go on, Brooke.
Okay, so the next question is it possible to transfer an entire design system from Figma over to Qt Design Studio that can be reused in multiple projects? So I think we take that a little bit step by step. Currently, it is possible to transfer an entire design system from Figma to Design Studio. However, in the current release 3.5 and the next release 3.6, that is only a local version of your design system from Figma. So you have to have that file in front of you in your workspace to use it properly. However, we are working on full remote library support. So the idea is that very soon you won't have to have the full copy of the design system. The design system can be created inside the team or organization that you're part of, and as long as that is shared as a library you have access to, you'll be able to use that design system in whichever project you want, and Design Studio will know how to import all of your components and variant sets and design directly from that remote library. which is a big step towards this sort of collaborative design approach. The final part of that question, can it be reused in multiple design studio projects? That's something where that's still a little bit lacking, let's say, in Design Studio. Design Studio itself does not have these strong collaboration features that Figma does. So of course you can reuse QML components, but there isn't a nice UI provided to do that automatically. It's something that if you have those components in a Design Studio project and you want to move them to another Design Studio project, you would have to physically copy them across from one project to another. But of course, this is something that we're very aware of, and that collaborative design is a very important topic. So all I can say for that part is that we are always looking into ways to improve the collaborative nature of Design Studio as well. However, I hope that for now, the variant support plus remote library support will be enough that most people can work collaboratively and can reuse design systems in their various Design Studio projects. So I hope that answers that one properly. And the next one is another Figma one. Let me jump in on that one too. This is, are there Figma coding style requirements, naming conventions, required to import variant states constraints into Design Studio? So it's a very good question. It's actually a really important part of the design process. Figma in itself doesn't enforce naming conventions anywhere except for using variants. Now, you don't have to use the syntax directly. You can use the UI to do it. But in order for Figma to generate these variant sets, the changes, it does have a certain bit of syntax, which is something equals something. And it doesn't have to be state equals normal or state equals hovered. It can be anything equals something and then a comma separation. Design Studio itself is very heavily, it's very important to have naming conventions inside QML. QML requires unique identification for each item that you want to have any kind of binding or assignment to. But the good thing about Qt Bridge plugin is it is smart enough to handle that for you. So if you haven't been through your Figma file and checked for duplications or checked for QML ID limitations, because there are some limitations to QML IDs, it doesn't actually matter. It won't break your import. The bridge itself will actually take care of renaming and iterating all of your IDs through the export process to make sure that it can work. However, from a workflow perspective or from a best practice perspective, I highly recommend that designers start to think about things like design token systems. So naming structure, naming conventions, QML ID, understanding the ID part of it, if they want to have a really nice clean import in the end. So for the demo projects that we share, that we ship, you can see in the Figma file that we take great care to make sure that everything is named properly. Every single layer, every single object, every single state follows a pattern that we define ourselves, but at least is consistent within the design. So it's not 100% necessary. The bridge will do a lot of it for you. I would absolutely recommend that you look into design tokens and naming systems as well, though, because it will make your imports that much better in the end. Okay. Thomas, do you want to take the next one? I think this was actually about, this was asked during the particle system demo, what the scale of the model is.
During the particle demo, I would assume this is the model of either the HVAC demo or the cluster demo. So if I remember, it's roughly like 200,000 triangles or so. So they were optimized for real-time use. So it's not like they are unoptimized, but really high fidelity. If you're interested, feel free. Both are part of your Design Studio. You can download them as on the example wheel page, and then you can check it out yourself. But I think it's around 200,000 triangles, something in that magnitude. Then the next question is, are these visual and particle systems able to run on light or embedded hardware, such as Raspberry Pi or equivalent? My first comment would be Raspberry Pi. In our context, we don't really consider that light for embedded at least. So Qt Quick 3D definitely works on a Raspberry Pi. I mean, yes, you have to be a bit careful, like cannot have too many particles or too large models, but in principle, it also works on a Raspberry Pi. And you have to basically try it out on a case-by-case basis, that you don't create like too expensive shaders, especially if you want the pixel shaders, and that you don't have too many particles in your particle system. And also transparency is something you really have to be careful with on something like a Raspberry Pi or an 6. The next question is, which Qt license does Figma import require? That is the Qt Design Studio Enterprise license at this point in time. So you need the Qt Design Studio Enterprise license, and then you get the bridge. Yes. Then the next question is also a very interesting one. Can we integrate the UI developed in Qt with existing Python applications? The answer is yes. I didn't really show this, but I showed you the Qt Creator C++ integration where our wizard generates a bit of C++ boilerplate code. We currently don't generate that boilerplate code for Python, but it's pretty straightforward. You could also deduct it from the C++ boilerplate code. And yeah, that would also work. And then all the QML would, of course, be dynamically loaded in Python. So you don't have to worry about things like build systems and so on. So in a way, the Python integration is a lot easier than the C++ integration because you don't have a build system. And yeah, it's really like 20 lines of code or so to basically import a project. The only thing you have to take care of, if we cover this here, is that Qt Design Studio comes with a custom couple of custom modules, and those have to be built for the Qt. But we are in the process of getting them to the installer, so you don't have to worry about this. Then the next question is, what is the main difference between a GUI created with Qt Creator and Qt Design Studio? So I assume you are talking about the integrated QML designer in Qt Creator, and the answer is there is no big difference. It's just that the integrated QML designer, we don't enable it by default anymore because there are many things that can go wrong in the context of Qt Creator. So the main difference is that Qt Design Studio brings basically the correct Qt 6 kit that works together with everything. It's well tested. In Qt Creator, you can use this, configure any kit from any Qt version. There are many things that can go wrong. If you keep the latest kit that's also tested in the context of Qt Design Studio and so on, it's more or less the same. It's just that Qt Design Studio comes with a few more tools like the bridge importers. It also comes with a couple of custom components that are not by default part of Qt Creator. But for most part, the implementation is still the same. Then the next question is it possible to animate 3D in Qt? And the answer is yes. So all the animation capabilities we have in Qt Design Studio, they are fully available for 2D and 3D. So we have the timeline, states, we have transitions. So yeah, you can easily do animation in 3D, and you can, for example, animate the camera using the timeline or using states. Then the next question is when Qt Design Studio 6 will be released. So because of summer vacation and summer break, we did not release last month, but Qt Design Studio 3.6 is supposed to be released end of this month, next week. So it's basically already in feature freeze, of course, and we have already released candidate that next week. That will be Qt Design Studio 6.3, and then we will release one a month again. Okay. Then there's the question: does the Figma to Qt bridge only work in Qt Design Studio, or could it also work in Qt Creator? Yes, it's basically part of the Qt Design Studio Enterprise license. That's more a business decision than a technical decision. But if you want to use the Figma to Qt bridge, you need the Qt Design Studio Enterprise license. Then there's a question about the graphical performance on embedded ARM hardware. That's similar to the question about the Raspberry Pi. And yes, performance is quite good, I think. And you might know that Qt also supports MCU and Qt Design Studio for 2D, even really supports Qt for MCU, which is even below or significantly below typical embedded ARM hardware, like an iMac 6 or 8 or Raspberry Pi. Yeah, for the 3D parts, it's a bit on the lower end, but it works. And for the 2D parts, I think that's really where this kind of hardware shines and where Qt Quick is developed for. Then there's a question, is it possible to export a Figma design directly into Qt C++, not QML? No. Kind of need QML as the intermediate language and representation at this point in time. And yeah, it would also be hard to define what exactly would be the outcome. Widgets don't have the flexibilities, the styling capabilities necessarily. So in theory, somebody could develop something similar just in C++ and then use the QML code to compile it. But that would basically be what Qt for MCU is, right? Qt for MCU can take the output of the Qt bridge, which is QML, and turn it directly into C++ again. And then we don't have QML during runtime. And also for the Qt stack itself, we work on a compilation chain. And you saw when I compiled the project that the QML code is already technically compiled to C++, technically compiled. And you have to be careful with what compilation means in this case. But the QML compiler is improved, and yeah, it's the resulting code is supposed to get more performance. The next question is the Qt Bridge plugin in Qt Design Studio 3.5 couldn't handle Figma mask and ellipse component, etc.
Shall I jump in?
Yeah,
I can jump in and talk about this one a little bit, Thomas, because it's again a very important observation, let's say, for the Figma bridge. Yes, currently we only are available to convert rectangles into quick rectangles and text into Qt Quick text. However, we are currently working on arcs, ellipses, and pi items, which can all be generated as QML components, and hopefully that will be in a relatively soon version that it will be able to do that. However, masks are something that we've really struggled to capture properly in QML. And I think that the problem is with masks is that we don't really have good equivalents inside QML itself to do this kind of dynamic masks the way that the design tools do. So I think for now, masks will always have to fall back to an asset-based export unless we have some kind of breakthrough where we figure out a way of translating a mask to a QML item. But certainly arcs, ellipses, and hopefully other shapes in the future, wherever possible, we always look to convert into QML directly, and where not possible, we fall back as gracefully as possible into assets and images of different file types. I can also carry on with the next one, Thomas. Does import from Adobe XD work? It has similarities with Figma. Yes, we, of course, are familiar with XD. We do have an Adobe XD bridge. And that's part of the download for the packages. Again, it's enterprise license only, but if you have an enterprise license, you can equally try out both Figma and XD. I would say one thing, that although Adobe XD supports similar features to Figma in their own front end, their API is lacking a lot of support for these features. So the reason that we can do variant sets and constraints and library stuff with Figma is that they provide an API for us to access for that. With Adobe XD, this API is not yet in place. So Adobe XD doesn't support states in the bridge, even though they do have states concept inside the tool itself. But we are always monitoring the situation with the design tools. And as soon as public API becomes available for XD, then of course we can implement the same features we have in Figma as we do in XD. So it might be worth, if you are really stuck with XD, to test the bridge out and give it a go. XD does have some nice advantages in that you can import your Illustrator files, your Photoshop files into XD and use that as a sort of compositional mastering tool to master all of your export information via the bridge there. And that way you can bring in a lot of legacy artwork directly from your Photoshop and Illustrator files. However, it doesn't have all of those full features that Figma currently has right now. So Figma is certainly very much at the cutting edge of what we are able to achieve with importing and converting into QML. Okay, let me grab this top question. Is the robot demo available for download to try out? Yeah, the robot demo comes as standard as part of every Design Studio installation. So whether that's the community version, the professional version, or the enterprise version, inside the examples page of your home menu is the full robot arm demo that was shown today. So yeah, of course, you can grab the latest version of Design Studio and test that demo out. Thomas, I think that next question is for you.
Let me read it out. So the question is, we are working in an embedded ARM controller such as the STM32F429 with custom graphics IC and customized PC board. Before this, we used RTOS to make interaction automotive meter cluster. Which license is the best with Qt? And there's also a question about performance on this controller. So what you would use in this case would be Qt for MCU. So not the regular Qt framework, but Qt for MCU. And I don't know in detail how the customized graphic IC, how well that is supported in your case. That would be really a question for one of our pre-sales engineer and support. But a bit of context, Qt for MCU is really the low-end version of Qt. It's also a bit different. It has the same name as Qt and it's compatible, and Qt Design Studio works with it, but it's a totally different implementation, especially for this kind of hardware. And that's what you would use in this case. Yes. Yeah, then there's the next question about .qml files and .uiqml files. So does Qt Design Studio support viewing .qml files, or should I only use UI.qml files? So this is, yeah, actually a good question. So when you use QML files, you're kind of on your own, because QML file basically means technically there's no difference. The .ui.qml file is simply for the tooling, and we enforce then the feature set. So the feature set is a lot smaller, and that basically guarantees that the Visibig editor continues to work. If you use QML files, you can add any feature, and the editor won't directly complain about it, but the Visibig editor is likely to break. So it's really your choice. If you want to use the form editor or the 3D editor, I would say use UI.qml files. If you're willing to take a risk and you really need something that is currently not supported in the visual tooling, like a bit of code or so, you have to use .qml files anyway. And if they work, they work. If not, then not. But what is always possible is to embed those .qml files again as components in UI.qml files. And that's usually what I suggest in these cases, is then the workflow. Then there's another question, whether can we import the FBX created in Cinema 4D into Qt Design Studio? Actually, I think Brooke did some research on that. I think, didn't we even create a tutorial for Cinema 4D or some documentation, but Brooke knows more.
Yeah, there's a documentation page for Cinema 4D. Wonder if I can drag it out and find the link. Maybe I'll open up a browser in the other window. I'm trying to remember, because I'm not really a 3D expert, what the other file, the other import format we use is. Because there's a 3D import file. This just might slip my brain completely at the moment. Do you remember, Thomas, what the other file type?
Or GLTF.
GLTF. So I'm pretty sure that when I was doing all my experiments with Cinema 4D, I exported everything as GLTF and then was able to import that without any problems into Design Studio. So I had created all my meshes and exported them as GLTF, and everything worked fine. I don't even think you need any extra steps there, just straight export as GLTF, import, and you should get everything that you had from your Cinema 4D file. But let me see if I can find the documentation page for this. I think I might have to look for it later, Thomas, because it's not coming up directly, and I'm not sure if it was actually a published page or whether it was still work in progress.
Okay.
Perhaps we can get back to the question asker with that information later.
Yes.
If we figure out a way, maybe you can reply to your comment with an email address that we can send you that page to. And then I can have a look through my emails and find the link for sure. But yeah, GLTF works. I know that for sure. No, it's an anonymous attendee. Well, okay. Try your best. Okay, there's still a couple more questions. What courses can you recommend to QML beginners? That's a tough one. Thomas, can you think of anything really good for that?
Studio, we have as part of the documentation a tutorial. I would definitely suggest starting with that one. It's relatively simple, relatively basic. There are many QML tutorials out there, but many of them are more tailored towards developers. Also, as part of the Qt documentation, we have a couple of videos out there. They're still slightly outdated. I think it's gone now. We don't even provide that anymore. So for now, I would really start with a tutorial that comes with a Qt Design Studio documentation, where you create a login screen, and that gives you a simple overview, and get familiar with that, and then maybe either continuing with the Qt documentation or also some of the videos that you find on Qt Studios on YouTube. And then this so far is the last question. The CMake build file generation for Qt Design Studio is supported for Qt 6. That's correct, and higher, but not Qt 5. Yes, that's correct, because Qt 5 is still kind of QMake based. It doesn't have this CMake based build system for QML modules and QML. So of course you can also get it working with QMake, and that's also documented, and even have an example for that. But then you have to use QMake, and it's not that automated. We can generate the QRC file for you from the UI, but yeah, it's a bit different. Yes, let me think if there's something else. No. But we concentrate on Qt 6 right now, and really try to polish the workflow for Qt 6 as good as possible. I think this was the last question. So sorry for the bad audio quality. We don't really fully understand what's going on here. Yeah, but thank you for your attention. Thank you for attending this webinar. And please try out Qt Design Studio, either 3.5 or just wait 1 week for 3.6 next week. And there's a bug tracker, and you can provide feedback. Yeah, that's it. Thank you from me.
Yes, thanks very much, everybody.
Thank you, everyone, for joining, and have a wonderful rest of your day or evening.